My microphone's turned off. Peace in, everybody. What's up? I had my microphone turned off, so that never helps. Hello, I'm Greg from Greg's Tutoring NYC. What's going on out there? How's everybody doing? So you guys should be through your first week of school, and hopefully that's going all right. Um, for those of you guys in New York City, you should have gotten the news yesterday that the SHSAT is happening in December. There's no more details yet. So uh, I have a little mini series here. That's what this is part of. This is grade 7. I think we're at part 5 or 6. And there's probably one more part after this because there turned out to be more harder problems than the other grades. I did grade 3, grade 4, grade 5, grade 6. You can look on my channel. You could also go to GregsTutoringNYC.com/hardest-problems. And you can find the links to all these there as well. So they're kind of organized. You don't have to basically search through the channel hunting and pecking for them. In fact, let me type that in here. So if you guys go to find the series, go to https://www.GregsTutoringNYC.com/hardest math. Yeah. So again, I'm sourcing these problems. I see some people piling in here and a few likes. Yeah, please subscribe and like. Um, this is challenging to do. So again, I'm sourcing these from the New York State math test over the past 10 years or so on. Because about a few 100,000 kids have taken some of these exams. And, you know, that's a good kind of track record to work from. So what I did was I analyzed all the past 10 years grade 3 to grade 8 exams, and I picked out of it the problems most kids get wrong the most. And a lot of kids getting, like, only 30% of the kids are getting them right. There's a few where it's about 50-50, but the majority of these, most of the kids are getting wrong. They're getting them wrong for a multitude of reasons. I want to not really focus on the problems. I want to focus on concepts and topics. I also want to focus on giving you guys alternate ways to view stuff. And also I want to focus on your numeracy, which is your mathematical prowess and things like that. So that when you see a problem, you can start understanding it at different levels than just trying to follow memorizing a formula or just trying to follow some rules robotically that you learned in class. So that you're thinking mathematically, right? That's key to a lot of this. I'm also doing these series because this becomes prerequisite material and prerequisite examples and prerequisite problems for those of you who are taking admissions exams for high schools and things like that, particularly ISEE, the SSAT, the SHSAT, the TACHS, the Bergen County Academy tests. There's just a plethora. The Hunter College High School exam. These are all, if you don't know these, you're not going to be able to do those kind of exams. As well, these are just basic good summaries, a little twisted summary, but also good summary of your grade level mathematical requirements, if you will. Okay? And as I'm going through the grades, obviously the problems are going to get a little harder. All right, so I would suggest you guys look through the whole series, including going back to previous grades if you need to. If you're catching us in the replay, you can look at the problem, pause it, try to solve it, and then see what I say about it, because I'm trying to look at alternates and different ways of approaching it, things like that as well. And while I'm not concerned about the raw problems and that being from a test, the flip side is that some of the practical uses of this is not only trying to solve problems in the real world and all those other kinds of stuff with it, but part of the practical use is trying to pass a test. All right, so we have to have that hat on, maybe not completely on, but we also need to understand issues of pacing, test taking skills, things like that. But we're really focusing on taking a problem, analyzing it, ripping it to pieces, and then trying to get the answer. Okay, that's really what we're looking at for. We don't care if it's an easy worded question or a hard worded question. We're still trying to look at that with a mathematical perspective. Okay, all right. So with that in mind, let's jump in here. Let me get rid of this. So we're going to go about an hour. Tuesday at 7 o'clock here. I'm going to go back to 8 o'clock. My tablet's going, so that's good. So let me get the pen working. Can it work? Yeah, there we go. All right, so let me just make sure we're live still, because I don't want to do an hour's worth of stuff if nothing's happening. Okay, we're good. Sometimes YouTube freaks out and does weird stuff, as well as this is technology. It's great when it works, and it's not great when it doesn't. All right, so if the expression, so I'm going to view this right here as an illustration. So all I know is it's a little piece of algebra. It's minus 3 times x. It's just a term. That's called a term. Okay? So there's really not anything that's going on there. We don't know what we have to do here. We can't even say, well, we need to solve for x. Because normally if you solve for x, there's an equal sign somewhere. You actually have an equation. So we don't know what we have here. So we're going to have to go back to the words. If the expression below, right, now I said it was a term, but it's an expression too, has a positive value, okay? So that means right there, if we stop, we're stopping mid-sentence, and we're going to basically say it's greater than 0, right? If it's positive, it's greater than 0. Okay, 0 is neither positive nor negative. So there's negative numbers, 0, and positive numbers. Okay, so what we basically did, let me get rid of that little square I drew on there, just to make that a little clearer, that we kind of taking the original expression and making a bigger expression, minus 3x is greater than 0, which inequality, okay, and by the way, I just wrote an inequality right there, okay, so let's just stop kind of again there. This is an equality. X is equal to 5, okay? It's saying that they're equal after that. This is also an equality. Y is equal to mx plus b. That's the equation of a line. Equation has equal within it, okay? So does inequality. Right? We have the word in and then equality, meaning not equal. So these are talking about things that are equal. Okay, and the inequality is not equal. So equal is our equality operator. Our inequality operators are less than, greater than, right? Less than or equal to. So it's a less than sign with a line under it, or greater than or equal to. So depending on the fonts, okay, there's also other ones, including an equal sign with a slash through it, which means not equal to, okay? So that's some additional operators. These are called operators. Just like A plus B, okay, that's addition. That's the addition operator when it's used like this. When we have plus 5, that means it's a positive number. That's not plus. We call it the plus sign, but it means a positive number. So we have this symbol, the plus. The plus symbol has 2 different meanings to it. Okay. So anyway, we're only concerned for this example about these right here that I'm circling with the purple right now. That's what the inequalities they're talking about are. So as you see, I just wrote one of them. All right. So since I took like 5 different sidebars, let's come back to the original question. If the expression shown below has a positive value, so if minus 3x is positive, which inequality represents all the possible values of x in the expression? Okay, so I just wrote this expression here, minus 3x is greater than 0. And yet, that's not one of the choices. But if you know your algebra, we can solve for x, right? So if I have minus 3x, why did it write a 1? Give me 1 second. If I have minus 3x, it's greater than 0. Okay, to get x by itself, we're going to divide this sign by minus 3, this side by minus 3. Okay, whatever you do to the left side of the equal sign, in this case, you do to the right side. So that's the same thing here. Whatever we do to the left side here, we're also going to do to the right side. So we're going to divide that by minus 3 as well. Okay, this cancels out, and this stays 0. So we get x is greater than 0. Okay, so there's one nuance that when we're not dealing with the equal sign and we're dealing with all the other inequality operators, if you're left with only x and a negative value as its coefficient, right? Minus 3 is the coefficient for the x here. If we divide as the last step, divide by a negative number, we flip the sign. So that means this is going to go that way. Instead of x greater than 0, it's x less than 0. And therefore, the answer is A. So there's a couple levels to this problem. So most kids probably said the answer was B if they got that far. And they would forget that last step. Okay? And some kids may have guessed this or used logic to solve it. All right? Because think about it. Let's take another perspective of how alternate way to solve this. If it's minus 3x, right, and they're saying it has to be positive. If it has to be positive, that means that x has to be negative. X has to be a minus something. We know that because we have this minus here and that minus. And a minus times a minus yields a plus. So negative number times a negative number gives a positive number. So the choice for x has to be a negative number. All right, so we could have solved this without going through this mathematical terminology and symbolism I used over here. We could have just approached it logically. Okay, and that's your double check, by the way. And that's how you want to have a lot of your problems set up. All right. All right, welcome. I see a few people in the lobby. Peace in, peeps. If anybody has any questions, please ask. I love for this to be interactive. All right, so let's go do the next question. We're going to go about 45 more minutes. So we might do, I don't know, 8 to 10 more questions. Hello, Mohammed. So which statement describes the decimal equivalent of 7/8? So this one also has multiple ways to approach it, multiple solutions. The straight out way to do it is this, to divide 8 into 7. And we know we're going to end up getting decimal parts here. So we're going to at least go 2 because we know it's talking about 2 and 3 here. So we might even need a third one here, depending on what it's really asking us to do. So it says, which statement best describes it? It is a decimal with a repeating digit of 5. Is it a decimal with a repeating digit of 75? Is a decimal that terminates after 2 decimal places. So this is talking about the answer is like 1.23. Okay, and this is terminates after 3 decimal places, and this might be like 1.234. So what you have to do with these problems is understand the problem, right? It's no good to think the answer like kind of looks like A, but if you don't really understand what C and D means mathematically, English-wise, conceptually, you're not going to answer all your questions properly. All right. So Anybody out there have the answer? Since a few guys are out there, let's try to stop making this interactive. We know 8 times 8 is 64, right? So we can do 64, and we get 6 left over, right? 8 goes into 60, 7 times we get 56, and we get 4 left over. And 8 goes into 40 5 times. And that's the answer. So 7/8 is equal to 0.875. So is the decimal repeating with a 5? Nope, it's not. Is it a decimal repeating the 7/5 at the end? No, it just ends. It's not repeating. Right? If it said a decimal with digits of 75, yes, that would work. But since it says repeating, B is out. Okay? Is it a decimal that has 2 decimal places? No, it has 3. It has a tenths, a hundredths, and a thousandths. And so C is out. And it's a decimal that terminates at the 3 places. Yes. Okay? The other way to solve this is that you guys should know what 1/8 is equal to. Okay? That's 0.125. And you kind of should really already know in your head what 7/8 is as well. You should know already that it's 875. Okay, and you should be able to do that computation fairly rapidly. I mean, you can come on the side and do 0.125. If you knew it was that, and then multiply by 7, you can do that, right? And again, some of you are on tests where you can use calculators. So in that case, obviously, the fastest thing to do if you're on a test that allowed a calculator would actually be to do the 7 divided by 8. Okay, make sure you type it in and actually do it twice just to make sure you actually typed it in correctly. Because one of the biggest fallacies of calculators is they give you the right answer, but you have to type in the right operations and the right numbers in the first place. All right. So anyway, that was the second way to do this, was to just know your fractions. So on that note, just to do a quickie, you should know all the 1 over x fractions. 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7, 1 over 8, 1 over 9, 1 over 10, 1 over 11, and 1 over 12. So I would do that from 1 to 12. Memorize those. And that's not as hard as it seems, because you should already know what a half is, right? You should already know what a third is. You should already know what a quarter is. You should already know what a fifth is. Okay? You should definitely know what a tenth is. So that's half of them already. Okay? And if you know what an eighth is, right? There's other ways to think about this too. If you know, for instance, that a quarter is 0.25, right? Because it's the same as 25 over 100. Okay? A quarter, an eighth is a half of a quarter. Because if we do a half times a quarter, we actually get an eighth. Okay? So all we have to do is take this and divide it by 2. We get 0.1. This goes in twice. We have to do one more over here, and then 5. So even if you forget what 1/8 is, you'll have a quick way to get an eighth by actually dividing a quarter in half. Same goes for something like a 16th, right? You can get a 16th by dividing an eighth by 2 and get 0.0625 out of that. So there's ways to do this to make some of this faster and so on. Or if nothing else, to be able to double check your answer, right? There's other ways to do that. Because what we want to do you want to actually solve things twice different ways. Because let's say you did the 8 divided by 7, or 8 divided into 7. Let's say you did that, and you made a mistake, and you thought it was like 0.2. Let's say you did that. Most of you, for your double check, is going to be to do the exact same thing again, and probably make the exact same error again. So what you did was you double checked your error by making the same error twice. So you want to do it in a completely different way. All right? And you can also do the reverse. Since you know this is 0.875 and you did that, if you multiply these two together, you should get it back to 7. Okay? That makes it tedious, obviously, though, because doing 0.875 now just to verify this. Times 8, that's starting to be a lot of computations that you have to end up doing. But again, this is about your numeracy and fluidity. And if you memorized 1/8 and memorized 7/8, and again, you guys should all know this, right? You're all top math students, right? You should know this already. So this kind of thing should be a no-brainer, so that if this was stuck in a word problem, if a word problem talked about like 7/8 of 80 or something, you should know immediately that what the answer is, right? Because you can have something like 7/8. Let me change the color here so you know where I'm writing. Seven-eighths of 80, which means 7/8 times 80. You know, it depends how it's done. This is canceled, that becomes 10. So that becomes 70. But if you were doing it, if you had to piece that off first and get to 0.875 and then do something with it later, right? Then it starts getting more complicated. So my point was, I said that very poorly. My point was that if you need to use 7/8 in a word problem, you should just know what it is, because it's going to make your solving your answer slower and more complicated and more error prone. And again, it gets back to your numeracy skills. Okay, number 21 here. Again, I'm going to look at the expression here, the whole expression, as my illustration. What leaps out at me is it looks like the distributive property. There's 3 terms there. There's 2 x's. So let me change that. There's 2 x terms right there, and then on the outside, I have the distributive property. The 1/2 against the 1, and the 1/2 against those 2 terms. All right? And then they want to know which is equivalent. So one of the problems with these equivalent things, we just saw it on the other problem, is the answer forms, the forms and the answer choices, they're not always in the form that you think they might be. So sometimes you have to do a little kind of hunting and pecking to get there. So this is a little more involved than it seems. So let's use PEMDAS, because in addition to this being the distributive property, what also leaps out at me is PEMDAS, right? Please excuse my dear Aunt Sally. I'm just going to write PEM, which is the order of operations. What's the order things should be done in? Okay. So I see there's 2 x terms, and they're like terms. So I would just combine them, especially since they're inside of the parentheses. Okay. So first I notice this is minus 3/2. Okay. So that's minus 1/2. Okay. Plus 6x. Okay. So that becomes 4.5x, right? So then we combine that, okay, plus 1 minus the 3x on the outside. Okay, and we still have that minus a half on the outside, on the left-hand side as well. Okay, there's no x involved there. So I noticed, I don't really want to do a fraction times 4.5. I could do divide 4.5, but I notice all my answers are in fraction form. All right, so this is the same as 4.5. So I'm going to do that conversion now, not quite knowing 100% if there's going to be a payoff to do it this way. Wait, I just wrote it the same way. Hold on a second. Which we know is equal to 8 9/2. Okay, so now what we have is minus 1/2 times 9/2. And anybody spot me if I'm making errors here. I have dyslexia and dyscalculia and dysgraphia, so if anybody sees me doing something wrong, just give a holler. And I'm actually going to stop at this line and make sure all my numbers are correct at this point. Just to be clear, I write sloppy, and I do not see numbers as they appear all the time. So I wrote a 9 here, I might see it as a 7. Not because it looks like a 9, just because my brain throws up different digits. So let me go through this one more time. That was minus 1.5 plus 6x. So that gives us 4.5, 5, 6, 4/2. 4.5 is the same as 4.5. 4.5 is the same as 9/2. All right, so we have that, right? So now we're actually going to finally do the distributive property. We're going to do minus 1/2 times 9/2. So we get minus 9/4. Minus 1/2 times 1. So that's minus 1/2 then. And this should have an x with it. And then minus 3x. Okay, so what I'm going to do is take this top-heavy fraction, the minus 9/4, okay, and we're going to write that as a mixed number. So that's how many fourths? I think that's 2 1/4, right? Let's see. 2 1/4, that's 8 plus 1, yep, minus 2 1/4x minus 1/2 minus 3x. So now we have to recombine like terms again, and our like terms are the minus 2.5x and the minus 3x. So that's equal to minus 5x minus 5 1/4x. And then we still have this minus 1/2 right here. Okay, and that turns out to be exactly choice number D. So there's a lot of steps here. This is kind of a deep problem. That might be why some of the kids got it wrong. Some of the kids don't know. A lot of you learned stuff like A times B plus C. Is the distributive property, but if if it is in the form of something like this, let me get rid of that. Plus, D. A lot of you guys are not clear what to do with the D. In this case, the key was that these two terms here actually combined. But even if this was Y, you guys don't know what to do. And this is just taking the outside term, multiplying it by the first, taking the outside and multiply the second, and then take the outside term and multiply it by the third. That's all that's going on there. So even if it didn't leap out at you guys that you needed to combine these two terms, you could still do minus a half times minus 3 half x, minus a half times 6x, minus a half times 1. That still would have worked. Okay? I just used PEMDAS and noticed that I could combine the both of them right here. Okay? And by the way, this is one of these problems where it's hard. There's really not an alternate except for what I just said. And in a lot of problems, you can feed your answer back into the question. This one's kind of hard to feed back in because you're left with something really conceptually involved. Okay? Anyway, you had to go through all these steps properly where you convert the fraction back and forth and all this other stuff. You could argue, by the way, let me change the color of this here for a second. Was that green? Yeah, it's green. You could argue the fact that I combined the both of these first here meant I had to convert to the decimal and back to the fraction. Whereas if I did the minus a half times this term and then the minus a half times that term, I may not have necessarily had to have done that conversion. Because minus a half times minus 3 halves gives 3/4 x, and minus a half times the 6x gives minus 3x, right? So we could have gotten the minus this in a different way, all right? Right? Does anybody have any questions about that? So this turns out to be a somewhat involved question. On the same note, it's a pattern question. This question can come up often on a lot of exams, both in your homework, your classroom, stuff like that. And the gotcha here is they're not asking for the actual answer as a number. They're not saying like x is 1 and what's the answer. And you have to find things that match back and forth. So it was lucky in this choice that this purple thing I'm circling now really matched directly with the actual answer. That's not always the case. All right, let's see how we're doing on time. So this one deals with some geometry. So we're going to look at the illustration first. I see a coordinate geometry that the x goes by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The y also goes by 1s. Let me just make sure I have this centered. The answer choices are not showing for a second. Let's just focus on the illustration. Okay. I have, it looks like a triangle stuck in a coordinate geometry thing here. I do notice that it says there's the key here, that each little thing here, say 1 to 2, is 2 meters. Okay. And there's a triangle here. I don't know if they can ask us for the perimeter, the area. Okay, normally if they wanted the area, they probably would have shaded it in. But let's see. We don't know. Let's try to figure out what might be going on here. There's really nothing else here. We know this is x. This is y. There's nothing else labeled. So it seems pretty clear without reading the words yet that they're going to somehow focus on the triangle. And by the way, this idea of looking at the illustration first, I think is very fail-safe, and it's something you guys should do. And always make sure you're looking at everything so that the word problem or anything of the problem doesn't start distracting you. So for instance, you were able to pick up the key here by looking at the illustration first. Whereas if kids do this, read this, look at this as part B, and then a C, finally go to the question. A lot of kids end up just skipping that there was a key here at all because they're so engrossed on trying to read the words. So you really need to give that few seconds where your focus is undivided attention is totally on the illustration, on every single problem. You notice I even did that on the ones that are expressions. I just made believe the expression was an illustration, which technically it is. So that you're focusing only on that, even though it's incomplete, you give your undivided attention to it. Okay? So now there's really nothing else available on the illustration. So now let's go look at the words. The scale drawing. So this is a key that there's a scale right here. That's what the key is telling you. That even though this says 1, 2, 3, 4, 5, it's 2 meters. It's not 1 meter. Okay? And by the way, there's no other unit on the if this was absent here, totally missing, there's no unit at all. So it would just be units, right? With that there, we know it's meters. Okay? All right, so let's go back to the question. The scale drawing of a field in the shape of a triangle is shown below. So they're calling this thing inside of here a field. Okay? So let's just say it was out in a yard or something, or on a farm or something or whatever, right? So that's what they're dealing with there. What is the actual area in meters of this field? All right? So we need to know the area of a triangle. Is one way to do it. There's other ways to do it as well. So the area of a triangle, I'm just going to draw a little triangle here, is equal to 1/2 BH. Let me make that clear. That's a 2. Okay. So what we can do is count here. Or we could take 2 from 9, and that's 7. So the 7 units right here. Okay, and let's double check it. 1, 2, 3, 4, 5, 6, 7. Okay, and then the height is going to be from here to here. And that goes from 7 to 2. So that's 5. Let's just double check that again. 1, 2, 3, 4, 5. Yeah, so that's 5. Okay, the problem some of you are going to have is you're going to do 1/2 of 7 times 5. However, that's no good. Why is it no good? It's no good because of this. Okay, this is through the key, this is actually 10 meters. That's the worst 0 I've ever seen in my life. And this then is 14. Okay, so if we just bring this up slightly, whoops, what I just did. These are our answer choices. Let me make sure that's fitting on the screen. Yeah, it is. So we're going to get 1/2 of 10 times 14. So the easiest way to compute this is do 140 divided by 2, it gets 70. Okay, so the answer is 70. There are other ways to solve this. So if anybody has any questions, ask, and then I'll show you some of the other ways. I'm going to erase what's on the screen right now. I think doing it this way was the simplest way to solve it, but I'm going to show you this way just so you can use an alternate way to double check your answer. Actually, there's more than one way to do it. Let's do the brute force way first. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 full ones. There's a half one here, so that's 13. There's another half one here, right? So that's 13. There's these two, that's 14. Okay? There's a half one here, so we get 14 and a half so far. If we go on the other side, they're larger than that. So this looks like it's almost a full one. So that's 15 and a half. Okay, it looks like these two together might be 16 and a half. And if we add this, that's about a half. So we get about 18, right? And if we multiply by the 2, we end up getting double that or whatever. So that's another way to do that. In fact, I counted that wrong. I did that wrong. It's off by a factor of 2 because actually, if I did it as if these were 1 by 1s, but they're actually 2 by 2s. So instead of counting 1, 2, 3, I should have counted by 4. Okay, and I came up with about 18. Right? 18 times 2 is 32. And if I double that, I get about 64. So the one that was closest to that was this. I was probably off by about 1 square there. Right? Do you see that? You should be counting by 4s. Okay, that's one way that's a second way to solve this. And let me erase those. And I'll show you guys a third way to do it. And again, it's good to know these other ways to double check. It's also good to know them that if the problem was worded slightly different, one of these ways may not have been appropriate or less efficient. So I'm less showing you guys these. One way, another way to do it was to put basically a giant thing around here. Okay, what we've broken this down to is 3 shapes now. A, B, C, and I'm gonna, whoops, let's see, and the whole rectangle here is D. Okay, so it turns out that D, the area of D, minus the area of A, minus the area of C, this was C, let me make that clearer, minus C is equal to the area of B, which is what we want. All right, so you can see that's more involved, but we have all the lengths and the heights, right? We have the bases and the widths of all these triangles, okay? Because we have this here, we have this here, we have this here, we have this here. So we actually don't need to involve triangle B. If we take the rectangle minus triangle A's area minus triangle C's area, we end up with triangle B's area because there's only anything that's left. Okay, there's still another way to do this. So we're really beating this to death here. Which is, we could have split this figure into 2 different parts. This right here, and I'll use a different color. This right here. So we end up with this, it looks like a rectangle in the orange and a square in the green. So if you notice, if we now label these as A and B, the area of A and B is the same. And if this was C and this was D, the area of C and D is the same. So all we have to do is get this is the base, this here is the height, and the same for this. This is the base, and this here is the height for that. And we just apply the 1/2 BH to both of those figures, and then we add the two of those together. Because if we're getting half of the area of the orange rectangle, which would be B or A, and half the area of the green square, which will be C or D, then we have to add them together because this is the area in here that we're shooting for. Okay, so again, depending on the question, I don't know how many choices I just went through now, about six different ways to solve this. And I think the original way was still the cleanest way to do it, but depending on how the question is set up and so on, there's alternatives. So we really beat that really well. And again, remember, no matter which way you use, you have to involve the key. So one of the keys to solving this problem, let me bring it back for a second, I'm flipping the screen around, was applying the 2 meters before you do the multiplication, right? Don't do the original thing over here, like 7 times 5, and then apply it. That's not going to work. All right? Because this is 1/2. This is 7 times 5 is 35. It's half of that. If you multiply that back, you're only getting 35 back. In the meantime, the answer is 70. All right? So be careful. So apply the key on an example like this as soon as it makes sense to do it. Not after you've computed the area. It has to be done before you compute the area. But by the way, when you do scales, there's some questions you're going to have to do about unit conversions involving scales. That's kind of the gotcha of that as well. Okay, so number 34 is pretty involved. All right, so some of you, unfortunately, may have never seen this kind of graph before, this kind of illustration. Let me just make sure this is fitting on the screen properly. We're not going to look at the answers for a second. I know they're not fitting on the screen. We're just going to focus on the illustration. Let me just shift that slightly because it's not right on my screen. Okay, there we go. So this is called the box plot, box and whiskers. So let's just try to grok out of here what we can. So this illustration is dealing with bowling scores. And it's telling us that, so this is the bowling scores as in this number line right here. That's what that title is for, okay? The bowling team scores is the title of the whole illustration, right? And then the Friday scores is right here, and the Saturday scores is right there, okay? So if you don't know what this is about, it can kind of get involved. So this left-sided whisker is the minimum number. And the right-sided whisker is the max. So you guys are supposed to know this, yet in some middle schools or with some classroom teachers, it's never discussed at all, and yet it's part of 7th grade curriculum through the whole country basically, but certainly definitely in New York State. So what do I mean by min and max? It means the bowling score. So this lines up, for instance, the Friday one lines up at 230. So the max bowling score that on Friday night would have been 230. The mid one lines up at, is it 185? Yeah, 185. Okay. This line right here, so if you notice there's a rectangle now, this line right here is the median. So I'm just going to put MED. So the median on Friday lines up with here. So what is that, 215? Right? And then there's two numbers here. This is called Q2, and this number is called Q3. And they're called quartiles. Quartile, as in quarter, because it turns out the min is actually Q1, and the max is actually Q4. Okay, except we're giving them more reasonable names. So what Q2 is the median of the median and the min. And Q3 is the median of the median and the max. Okay, so this is used in statistics. I'm just going to put stats here. I'm mentioning some of this because I could just tell you guys to look at box plots, but you might end up in the wrong part of the internet or something like that. So if you know some of these phrasing and some of these terms, you could kind of start figuring it out and so on. All right, so here's what I'm going to do because I kind of cluttered the screen, or actually, so that's what's going on there, and it's the same for Saturday. So the min score was 175 on Saturday. The mean on Saturday was 205, I think. 5, 10, 15, 20, 5, 10, 15, 20, yeah, 205. And the max on Saturday, if you notice, is between the two lines here. So the max on Saturday is about 200, I don't know where exactly it's being drawn, but it's 222, 223, 222 and a half, something like that, okay? We don't really know. And hopefully the question either doesn't involve that or it's not looking for something very exact. Okay, normally when we see an illustration of a box plot like this, it's going to ask us like the difference between the two maxes or something like that. So if they did that, or the difference between the two mins, we have 175 on Saturday and 185. So the difference between the two mins is 10, right? 185 minus 175. The difference between the two medians is 215 minus 205. It's also 10. Okay, the offset's not the same on both days. It just happened to accidentally, coincidentally, be the same here. All right, so we beat this to death. It's about two days of bowling, I guess bowling teams or whatever. So now let's go back up to the words. A bowling team participates in the 2-day tournament. Cool. Okay, and records the scores for each team on both days. Cool. So that's pretty much obvious now that we see the illustration. The scores for both days are represented by the box plots though. Okay, so I'm going to scroll that off the screen so we can fit the answers. Because there's no data involved in that. And what we need to do now is compare some of the information that's there. All right, so it looks like it fits on the screen, so let me go back to that. So which conclusion can be drawn from the box plots? So the scores on Friday and the scores on Saturday have the same median. Okay, well the median is here, and this median's here. Let me change the color. Give me 1 second, so we know what we're talking about. So this median's here, and this median's there. Okay, they do not have the same median because they're in different places. So that's false. They gave an and here anyway. And interquartile range. So the interquartile range is subtracting the two ranges. So we don't even need to do that. We don't even care it's true because this is already false. So A is no good. All right. The scores on Friday have a gradient median. So we have to stop there, and a graded interquartile range than the scores on Saturday. So does Friday have a graded median? Yes, it does. So that's true. So now we need to look and see, does it have a greater interquartile range? All right, so we need to subtract those two values. All right, and when we do that, it's false. Okay, and what it's really asking is the length of the two whiskers is which is greater. Okay, so B is no good. Okay, the scores on Friday have a greater interquartile range than the scores on Saturday. We just ruled that out, so that's already false. We just ruled that out. But both data sets have the same median value. We know that's false as well. So if we did all this correct, so and C, both of them are false, then D has to be the answer choice. Okay, so let's see. The scores on Friday have a greater median than the scores on Saturday. Yeah, it did, because this line was there. But both data sets have the same interquartile range, right? So if we do that, what do we actually get there? We get, this was 220. So for Friday, we get 220. Minus 200. So we get Fridays was 20. I'm gonna put IQ into quartile is 20. And Saturdays into quartile. So we get 210, right? From 180. So that's also 20. So that confirms they're the same. All right. So D wins hand down for two reasons. So again, if your school never did this type of charting, illustration, graphing situation, it's something you guys need to study, especially you guys who are taking things like the SHSAT. This doesn't come up on every SHAT. Same if you're taking the ISE or even the Regents and stuff sometimes. These don't appear every time, but they're possible that they could. So, and this is one of these things that I never talked about at all. And if you happen to go to a good mid school, it was talked about, but not in depth. It was probably covered in fifth grade and then again in sixth grade, like for one session each, and then done with. So this is not something that a lot of time is spent on. And the real world is actually complicated and pretty involved. I use these to do stock trading and stuff like that, because you can get the high and low of a day. It's median for the day, it's average for the day, and it's it's quartiles and so on. You can make, if you're doing graphing and charting, there's various patterns and so on you can figure out from it, make inferences, make predictions. Okay. All right. So let's see. I'm not sure how many questions we actually did so far, because I was hoping to only have one more session after this. Oh, there's still something underneath here. Let me double check and see when I started this session. We're going exactly an hour right now. At least that's my streaming software. So YouTube probably has it at 50 something minutes. All right, so let's see how bad this question was, and we'll either stop here or not. So instead of them making this as an illustration by itself, they made this expression as part of the thing here. All right. So it's pretty similar to the others. And by the way, on something like this, be careful. These A, B, and C is using a plus sign, right? It's easy when you're taking these tests to confuse a plus sign. And sometimes there's bad fonts that have a divide sign like that, where those two dots are either larger than normal or they're really smacked up in there, and they often end up looking like a plus sign. So be careful with that. That's not the case in this exact question, but it's just something of like a kind of a heads up for you guys. So let me get rid of this line I just underlined. Why is that not working? Come on. Whoa, what's going on? My software's freaking out. I think I may have just shifted something around here. Give me 1 second. Misaligned the my hand's shaking now. Is that right? Nope, that's not right yet. Come on. Okay, hopefully that's good. Okay, let's go back to that question. All right, so we're just gonna do the distributive property here, just straight up, because that's what's involved there. We're gonna do PEMDAS. We see the paren there, and then we have a distributive property. So minus 3 times 5h, that's gonna be minus 15h. Right? And we have minus 3 times minus a half, so that's plus 3/2. So if we did that right, without doing anything else, we know the answer can't be B because that's minus 3/2, and it can't be D because that's minus 3/2. Okay? So we have minus 7/2, right? And minus 15. So we can convert this to 3.5 if we want. All right? And we're going to end up, and that's H. And now we have to combine these two terms, right? So what do we get for that? Is that 11.5? 11.5 each. And since 15 is larger, we have to keep the minus sign. And that's the same as 22/3. Sorry, 23/2 H, which means the answer is A. Okay? And a lot of kids got this wrong. I'm not sure why. Again, I might deal with the distributive property. It might be a PEMDAS issue. It's so easy on these because you're keeping track of multiple things at the same time, like PEMDAS, the distributive property, all this kind of stuff like that. And it's so easy to forget about that minus sign, right? So just to be clear, if we have minus A times, I don't know why this software keeps making that a straight line when I do a curved line. B Well, let me do it the way that I was going to do B plus B minus C. Remember, the first thing I'm going to do is minus A times B. And that'll be minus AB. And then we're going to add to that minus A times minus C. Okay. Well, a minus times a minus is a plus, so this collapses into just AC. All right, that's what we get, minus AB plus AC for this here. All right, so we're going to use that on the outside there. There's another way to approach this, which is to ignore the minus sign altogether. Let me write it over here so that you guys are clear on all the alternatives and stuff for these kind of things like this. What we can do, and I'm going to use a square bracket just to make it clear what we're doing here. So what we're going to do is the square bracket first. So we're going to get AB, because it's A times B, okay, and then A times minus C. So plus A minus C, or just minus AC. Okay, so if we square bracketize that, we'll maintain the integrity of the square brackets. Minus that, this works the same way. So this is equal to just minus AC, sorry, minus AB, and then we have a minus minus, so that's plus AC, which is what we got right here. Okay. So again, we're using our identities, we're fluidity, the rules we know, the knowledge we know. We're just combining it in all different alternate ways to maintain the mathematical integrity and build up our mathematical prowess. All right, let me see how bad the next question is. If it's easy, we'll do it. If not, we'll end here. That's a little more involved. Let me see about the next one. That's a little involved as well. All right, so let's call it a day here, and we'll continue on the next time. Maybe there's going to be 2 more parts. If some of these are easier, then we will do it the other ways. Hopefully, you guys are enjoying these sessions. You know, this takes a lot of my energy, so please like and subscribe. Set the notification bell on, right, guys? And pass the word. Share. If you have any questions, write comments. And hopefully you guys are doing good. I'll continue the series. And for those of you who are taking the SSAT, as I had said, let me just throw this at the very bottom here. The SHSAT is going to be in December. Registrations is in mid-October. I will be doing SHSAT streams, but I'm probably not going to do them until I finish this. And this is the grade 7 hardest math problems and the grade 8 problems. There's going to be 5 or 6 sections of that probably as well. All right, so and the grade 8 ones are going to be really appropriate for the SSAT. So if anybody finds these too easy or whatever, and a lot of them kind of are for that level of testing, the grade 8 ones are going to be more involved. And again, these are the ones that kids are getting wrong the most. So especially if anybody joined my stream yesterday about the SSAT, the number of silly errors you guys make, or what's called silly errors, they actually call it not understanding math, but we can categorize them as silly errors. The number of questions you guys get wrong that are categorized as silly errors is astronomical. Okay, so you don't want to get 10 questions wrong out of silly errors, because I'm going over hard questions now, and these are the questions that are the ones that you're going to get wrong with the silly errors. All right? All right, so with that in mind, everybody, I wish you guys a joyous day, and peace out.